I shave my beard and I don't want to be the one oddball that does it, during COVID. It just seems like every guy has this really scraggly beard nowadays. So I need some company. Stick with me as we shave this hard level problem of our bucket list. Missing positive or first missing positive. You're given an array ARR. Find the first missing positive number in the array. And we've mentioned in bold, do not create another array, solve it in place with a constant space complexity. In other words, no arrays, no linked lists, nothing of length n or more. Try to solve it in a time of O of n. So we can see our input is n and the array itself, where n is the size of the array. Let's have a closer look at this array right here. Now, what's the first positive number? That's 1. But 1 is already in the array. So are 2, 3, 4, and 5. However, 6 is missing, which is why the first or the lowest missing positive number is 6. Now, the array can also have negative numbers and zeros, like we see here. What will the first missing positive number be in this case? We've got 1, we've got 2, 3, 4, and 5. But we're missing a 6 here again. So our answer will be 6 in this case. Now guys, the screen's open. You can head on to the link down below and try to solve it for yourselves. Once you're done, come back and make sure to watch the rest of the video. So the first thing we've got to do is try to figure out the range of the answer. What's the minimum possible answer and what can the maximum possible answer be? The minimum possible answer is naturally 1, since that's the first positive number. If there's no 1 in the array, that will be our answer. That's not true in this case. What can our maximum possible answer be? The length of this array is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the length of this array is 9. If it had numbers from 1 to 9, so say the array was 1, 2, 3, 4, 5, 6, 7, 8, 9, the answer would be 10. And that's the maximum possible answer. If we replaced any one of those numbers, then our answer would be less than 10, which is why the range of our answer is from 1 to 10. In other words, 1 to n plus 1, where n is the length of the array. Let's try subtracting 1 from that, and we get values from 0 to n. What else do we know? What else is there in our question that also has values from 0 to n? And what do each of those values signify? Once we figure that out, we're most of the way there. We've almost solved our answer. Since this is a hard level problem, we could do with a second hint. Let's also try replacing all the negatives and all the 0 elements with another number. Let's try replacing it with, say, 1. In that case, our array will look like this. Now, while replacing it, we've got to make sure to check whether our array already has a 1. Because if it doesn't, then we've changed our array and there's no way to know what the old array was. So we've got to make sure to check whether the array has a 1 or not. If it doesn't, we simply return 1. But if it already has a 1, we're simply adding more 1s on top. And the elements we're changing don't contribute to the answer anyway. So once we've changed all the zeros and all the negative elements to 1, this is how our array will look. If we couple this with the previous hint, that is to say, with this knowledge and with the knowledge that the answer can only be within the range 1 to n plus 1, we'll be able to arrive at the solution. Now guys, this is the solution right here. What else has a range from 0 to n or 1 to n plus 1? The answer is our array. The array itself has that range. We've got n elements in the array. Now that doesn't help us by itself, but we've also painstakingly converted every 0 and negative element to a positive element. So now we've ensured that each and every single element in our array is positive. So if it mysteriously becomes negative, that means something has changed. That means some value somewhere has caused it to become negative. That's what we're going to do here. What we're going to do is traverse through the array. Whenever we find a value in the required range, that is to say in the range 1 to n plus 1, we're going to update the index at that position. So let's have a look at 7. Now our entire array has a length of 9. So 7 is well within the range. We go to the 6th element. We subtract 1 from 7 because we're going to be dealing with indices. So we go to the 6th element, 0, 1, 2, 3, 4, 5, 6 right here. And we convert its sign to negative. So the moment we encounter a negative element, that's going to be our cue. That's going to tell us that there is an element somewhere which has the value of that index plus 1. So in this case, the moment we encounter 7, the element at position 6 becomes negative. Similarly, we're going to go to the next element, 2. Subtract 1 from 2, it becomes 1. So the element at position 1 is going to become negative. When we encounter the next element, 1, the element at position 0 is going to become negative. Here, there is a duplicate 1. We don't want to convert negative 7 back into 7 because that means it's unvisited. So if it's negative, we leave it be. Or what we can do is make sure to convert it to minus 1 times its absolute value. If it's positive, it will become negative. If it's negative, it will remain negative. Once we encounter this element, it tells us position 2, 0, 1, 2 becomes negative. Once we encounter 5, the element at position 4 becomes negative. And here again, we've got to be sure to check its absolute value. So the absolute value of this element is 2. What does that mean? We update the element at position 1. Similarly, update the element at position 3 and at position 0. Now we're done. We've reached the end of the array. And what does this new array tell us? It tells us that the first 5 elements have already been visited. That is to say 1, 2, 3, 4 and 5 are present in our array. But since the 6th element or the element with index 5 is positive, that means there is no element with value 6 in the array, which is why 6 is going to be our answer. If our entire array is filled with negative elements, that means our answer is going to be the length of the array plus 1, because that will only happen in a case where every single element from 1 to n is present in that array. Right here we can see it's surprisingly small for a hard level problem, isn't it? So first we assign a check variable, a checker. We iterate through our array and convert every negative element and 0 to 1. Simultaneously, we check if a 1 is present in the array. If it isn't, that means we just return 1 straight away. If there's no 1 in the array, our answer is 1. If there is already a 1 in our array, that's when we proceed further. What we do is, first, we get the absolute value of the element we are at currently, and we subtract 1 to make it an index. If that new value is in the range 0 to n, we convert the element at that location to a negative element. So we're taking its absolute value, and since we're multiplying that absolute value with minus 1, it will always become negative, whether it's negative or positive. Finally, we simply iterate through the array, and the first non-negative or the first positive element we encounter is going to be our result. If there is no positive element, in other words, if every element is negative, we return the length plus 1. N plus 1 is going to be our answer. Let's see if the compile and test button works. Yeah, a sample test case has been passed, and submit should give us a perfect score. There we go. So guys, that's the solution to this problem. I hope you liked it. We're going to be tackling a lot more hard level problems, so it's sure to get those brain juices flowing. If you like the video, hit the golden tree on your screen and make sure to leave your comments down below. We love your feedback. It's been Vivek Kolur, guys, and I'll see you all next time.